And welcome back to another video here from the Off-Grid Garage in sunny Australia. It is super sunny. Look at this, not one cloud in the sky today. Amazing. So best winter day so far. Where do I start to explain all this? In one of the last videos, we have fully charged the Seplos Mason battery pack here and found that the built-in Seplos BMS was not capable of balancing these cells correctly. At least we couldn't see any progress in balancing. So I connected actually the active balancer to it. Well, this has sorted the battery out, right? And the battery was perfectly top balanced. We then did a full capacity discharge test and found the battery has around 132 ampere hours available capacity if we discharge all the way down to 2.5 volts. And now I have actually managed to recharge the battery again. Well, I had the small power supply connected and charged with 5 amps, and then I charged with 20 amps. But all this power here is coming off my big battery, and I wanted to do something faster. I actually connected our pool fan solar system here with this solar charge controller directly to the battery. Usually this one here is connected to these two bus bars, which are then using this 4mm cable going through our top battery shelf department to a 25 amp breaker. And then from there onto our main bus bar. There you can see it. And then it goes onto our main bus bar system here and provides power to our main battery banks here. So as you could see, the breaker is actually turned off here, so there's no connection to our cables anymore, and these bus bars here are not connected to our big battery anymore, but they were connected to the solar charge controller. And I used these orange cables here to connect to our bus bar, and then I connected it to our battery. And this morning the battery was charged to 51% state of charge. I said, well, it will be charged to probably 75-80% today, and tomorrow I can make then the video and show what happens when the battery gets actually charged from solar and how the Seplos BMS handles that and what is actually happening then. Yeah. Well, surprise, surprise, the battery is actually fully charged to 97.8%. And also I could see it already, the green light is on, we are on float in the solar charge controller. So we had a bit more sunshine today as I was expecting it, which is fantastic. Yeah, we can see we are on float already. We still have 120 volt available, so there's still sunlight out there. And I can show you the settings. These are usual settings I have. 55.2 absorption for 1 hour. And then it floats and then it goes down to float voltage of 53.6. So this is 3.45 and 3.35. And because there's no load connected, nothing, it just hovers now here at 55 volts and it's not moving. And also the cool thing I saw is there's no warning, so there's no over voltage disconnect or anything like this. So I've got the big hope the Seplos BMS had sorted out this battery without any active balancer, without anything, just charging from solar as you usually would do, and everything is in balance still. Let's have a look at the software. Okay, let's connect to our battery here. Yeah, there's no warning, see? There's no warning. So what do we have? 20 millivolt deviation. That is not too bad. Cell number 14 is our high and cell number 12 is our low cell battery. 97.8 bus voltage. Okay, what I want to do now is, let me go back into our solar charge controller here as well. Go into the battery. And we want to raise the float voltage to 55.2 volts again. So this should actually push some energy into the battery again. It shouldn't take long. So I want to go back to the to the absorption voltage. I want to see what actually was happening at this point of time at this higher voltage of 55.2 volts. This always happens when you're not at home and you're at work and you cannot control anything and you cannot see anything. So voltage difference is 20 millivolt, 22 millivolt, and well, we are charging with half an amp only at the moment, so The 55.2 volts is probably the maximum you want to charge the battery to, and this gives you already 99.8% state of charge if you leave it there for an hour to absorb. So the current actually of the charger should have tapered off to almost zero after an hour, holding on this voltage. So while we are waiting for this one to recharge, we can have a look at the history here. Holy smokes, you can see here we have actually generated today 3.58 kilowatt hours, and this is only with these 6 panels here sitting against the pool fence and this sunshine today. Isn't that amazing? This is mind-blowing. Used solar panels against the pool fence, temporarily wired to a solar charge controller, and then recharging 50% of this battery. So this was, yeah, it is 6.9 kilowatt hours. Half of that is 3.5, and this is exactly what we have charged into the battery. So the math makes sense here. But I think we are not strong enough anymore to charge the battery up here to raise this voltage to 50. Okay, I probably use the power supply now. There's not enough sun anymore. It is already after 5 p.m. So okay, so I've now set the power supply to 55.2. This is exactly the same absorption voltage the solar charge controller would do anyway, but because of lack of sun, we use this one now. I've connected positive negative to our bus bars here as well, and we're charging the battery through that. And let's turn this one on. Okay, let's turn this one on and see what happens. 5, 7. Yeah, and then it tapers off already. Look at the current. Oh, you can see the current anyway here on the screen. I'm still not sure when the Seplos BMS actually balances. Does anyone else know when it's balancing? I've got these flashing battery symbols here, but I don't know if this is balancing. I actually don't think it is. Okay, so we have now reached the 55.2 volts, our absorption voltage. Again, this is what the solar charge controller would do anyway. And then it would wait 1 hour. And we can see here we've got a deviation of 31 millivolts. And now the balancer of the BMS should actually kick in and balance the cells, so discharge the high voltage cells and wait for the other ones to catch up. But I'm not sure how we can verify the balancer is actually working, because the last time when we tried it, we could see the deviation, the voltage difference actually rising, and then we connected the active balancer and it was collapsing. It was just balancing it out very quickly, but the internal balancer of the BMS didn't seem to work quite well. But I need to ask the Seplos engineers again how this balancing actually works. We know it's a passive balancer with 150, 160 milliamps. Is it just a charge balance, or does it need to see a charge current, or does it balance all the time when we are over the threshold to turn it on? It doesn't say anything about the balancing in the manual, but now we can see the charge current going down to 0.7 amps. So this is fully absorbed at 55.2 volts. And well, I think potentially we can go up with the voltage a bit and see how the voltage difference. So if I go up 0.8 volts, that would mean, so 56 gives us 3.5. Okay, here. So 56 volts I have set. The current is going up, it's charging the battery, and it's tapering off because already absorbed. Yeah, this shows again it's not worth charging any higher with the voltage. This is just for testing again. Now we get the single high voltage alarm because some of the cells are going over 3.5, and this is the threshold set in the software to give us an alarm. This is not the disconnect or something, this is just an alarm. And we can see here the deviation is going up to 50 millivolt now, where I would say the balancer need to kick in now and do something. Okay, I would say let's leave the battery sitting here for 20 minutes, 15-20 minutes or so, and see if the deviation goes up or down from these 52 millivolt at the moment. Ah, here. Equalization operation number 9. That's the equalization opening voltage. This is when the balancer starts. This is at 3.4 volts. This is how the BMS came. So does it actually balance at 3.4 volts? I don't know. Okay, let's leave it here for 15 minutes. We've got 53 millivolt, 54 now. And let's see how far we come within 15, 20 minutes. So it is now exactly half an hour since the last video clip, and we started with 53 millivolt and we are now down to 42 millivolt. And because I left the power supply connected to the battery, the voltage actually cannot sag down as it usually would do, because, well, when the charger is gone, it goes down to 3.4, 3.3 or something then. But it also has turned on this weird intermittent power supply waiting again, this warning, which actually prevents us from charging any further. These settings are so weird. So, where is it? Here. Equalization, open, this column, shit here. Equalization, opening voltage 3.4 volt. This is when we start balancing. Here in the function switch setting on the right, if you scroll all the way down, at the top you can find the charge equalization function is turned on. So this means we have a charge balancer, obviously. So only if the BMS sees a current flowing, it will actually balance. This is what I always experienced with all the other BMSs. If our current is under the threshold, it won't balance anymore. And as you know, I don't like this function. But then there is also a static equilibrium, a static balancing function. So does this mean it balances even there's no current? Can we turn this on and off individually here in this BMS? Which is great. I mean, if this is the case, it would be amazing. So both is on, and again we are down here to 41 millivolt deviation. But because we've got this warning now, the intermittent power supply waiting now, it is actually disconnecting the power supply, and you can see the voltage is actually dropping now. So will our deviation. So the whole test is again totally screwed, because we cannot further charge this battery unless I go under 69%. Just so bad. How am I supposed to do tests with this battery and this BMS? Oh, wow. And let me tell you, they have some weird functions in here. Like the intermittent charging function. It is turned on. What is an intermittent charging function? No idea. A transient overcurrent lockout. What? Oh, here, the take the initiative current limiting charging. I mean, what the heck? Well, guys, anyway, we cannot continue with this test here. So we could actually see the voltage difference during holding the voltage at 56 volts was coming down from 53 millivolt to 43 millivolt. So I'm not sure if this 10 millivolt is actually thanks to the internal passive balancer of the BMS. But nevertheless, usually it's not a problem if you have like 20, 30 or 40 millivolt deviation in your battery pack at this high voltage. As long as you don't go over spec of your battery cell, so over 3.65 volts, everything is fine. But as we have seen in the last test with the Seplos Mason battery here, as soon as I connect the active balancer to the pack, it balances fairly quickly, and within a few minutes it is almost balanced to under 5 millivolt. So I'm not sure if the internal balancer is actually capable of keeping this battery pack under control here. Especially if you don't fully charge every single day, you know. And then, like me, use the battery between 40 and 80% for a couple of weeks until you fully charge it the next time. And then your balancing could be totally destroyed. It could be totally... Then you have a passive balancer with 150 milliamps. You know, they all produce these nice active balancers here and nice BMSs like the JK BMS or the JBD BMSs or something. Why are they not putting these two together in one device and create a balancer which has 5 amp active balancing current and a nice app like the JK? I don't get it. Why are they still producing BMSs with 80 or 50 or 20 milliamp balance current only? This does not make sense to me. Well, I have to bypass the BMS now. So let's turn it back on and recharge to 56 volts, because the internal balancer of the BMS here should still work, even there's no current going through anymore. But I want to keep the battery here at 56 volts for a while and actually see if the delta going down. So we are back to 41 we are charging with 700 milliamps. It was still charging with 130 milliamps or something when this warning came up. The intermittent power supply warning. And then the BMS disconnected our charger for some reason. I don't know. And then also everything goes to 100%. So it says 100% state of charge. Here, 100% state of charge. And the remaining capacity is 130.87 ampere hours. So this is what it learned the last time when we tested it. Okay, so we are now at 42 millivolt deviation here. I just leave it running for another hour. Yeah, after dinner, and then we have another look here and see what's going on while the kookaburras outside have I just need to find out if it's actually balancing or not. So let's find out. Look at this, interesting. Changes from 30 to 100 milliamps and goes down again. As if something takes energy away and the charger recharges that and then it goes down again and waits for the next one. Could be the internal balancer. Well, it is now 2 hours later than just before. Let's start the Seplos battery monitor on the computer, because otherwise we cannot see how large the deviation is. It doesn't tell you on the display. You have to start the computer. An app would be so nice. Okay, let's connect and see what we have. Ooh, 21 millivolts only. So you can see we are still at 56 volts and deviation has gone down from 41 at 6 o'clock to 21 millivolt at 8 o'clock. So in 2 hours, 20 millivolt. It is a very slow balancer. But it is balancing, but very, very, very slow only. Yeah, not good. I want to increase the voltage again to 56.8, which is 3.55. Is that correct? I think it is. Okay, so we don't see any current on the BMS because we are bypassing the BMS. The BMS does not allow any further charging, nothing, right? So you can see here negative and positive are directly connected to the battery, and the BMS is only monitoring the cell voltages, but it is still using the internal balancer, of course. You want to see the current. It's only 1 amp, so it is tapering off. But I want to see how far the deviation actually goes up if we really go to the limit of the charge voltages. 31 millivolt. It's not too bad. It's still within the specs. None of the cells is over 3.65. Another hour or so, I think the deviation goes down again. But I want to go a little bit higher to 57.6, which is 3.6 then, exactly. Okay, we do this slowly. Don't want to cause any dramas here. 57.6, you can see the voltage climbing. And we still have 36 millivolt deviation. So we don't have a cell which is running away anymore. Yeah. And now the BMS would have shut down everything because we have reached the total pack voltage protection, which is 50, I think 57 volts or something. Yeah, I've said it too. Still we are at 39 millivolt deviation, so it's not too bad. So let's go a bit higher to 57.8. And just, we are still charging with 2 amps, 42 millivolt. We are now at 58 volts. That is a lot of volts. And we are at 44 millivolt, still within the specs. There's one cell going over 3.65, which is cell number 14. Yeah, that's right. 3.65. Charging current is 770 milliamps. So cell number 14. Let's see if the balancer actually pulls this one down. It's only 1 millivolt over. Totally fine. So I would consider this pack as totally balanced now. Even we have 46 millivolt deviation across the 16 cells, but they're all coming up with the same speed, the same voltage increase, and that is fine, I guess. Well, cell number 14 is still at 3.652, so it's not really changing. I was expecting the balancer now to kick in and discharge it a bit. It can't, because we are still charging with 450 milliamps. And if the internal balancer is really only 150 milliamps, it's still a plus of 300 milliamps then into this cell. So the voltage should actually go up still. I could potentially connect the active balancer now to the whole pack here and make it really 100% top balanced again. But I want to see what the internal balancer actually does here. If it can, it can't. See, cell number 14 is still rising. We are charging with 380 milliamps and taking 150 of that away with the balancer, if the balancer does that. And unfortunately, the balance cables are so short, I cannot get my clamp meter around it here to measure. What a shame. So there's still no proof that the internal balancer actually works, kind of, you know. So 47 millivolt. Come on. Give me some proof that you actually can balance. Deviation needs to go down. I need to see it actually goes up. Geez, Seplos, please. It's such a high quality and very praised BMS, and they include a 150 milliamp passive balancer. And it is this open design PCB. You can actually add supercapacitors and an active balancer. It is a bit more bulky then, but it doesn't matter. It doesn't need to fit into a case or something. Just add an active balancer and don't have this. Look at the deviation, 48 millivolt now. Still charging with 300 milliamps. I mean, this is the highest cell voltage you can actually have now. And still the balancer cannot push it down. Oh, 46. Finally, it is falling. Finally. Here we can see cell number 14, 15 and 16 are under 3.65. There we get 45 millivolts. So we can see, we can prove now the internal balancer is actually working, but very slowly. Okay, I turn off the charger now. I disconnect the charging leads, and I probably will connect a inverter now, the 48 volt QUCC inverter here to this pack, and discharge the battery a bit, because it sits at 58 volts now, and I don't want to leave the battery at this high voltage at all. So, okay, this was more to prove what the battery actually does when we fully charge again without an active balancer connected, and let the Seplos BMS do everything itself. And, well, we have seen it can handle it, but it is far from optimal, far from what I would consider. I trust the BMS to handle these situations. So I still like my option here with the active balancer. I can connect from time to time and do a full top balancing again and help this BMS out a bit. By the way, Seplos was actually so kind to put another PCB here in the mail, because they are not able to send me these temperature sensors here separately. Obviously, they are buying these PCBs as well, and they just sent them out as they are. So this should be in the mail in the next couple of, I don't know how long this will take. We will see. And then we have to replace the whole PCB here, unfortunately. Okay, guys, anyway, this experiment from today, checking out the BMS again, the balance function without active balancer, kind of, this was my whole point, actually getting two of these batteries to see how this BMS actually communicates, what the benefits are, if there are any benefits. What is it doing if one cell is peaking and turning off this one battery bank? What is the other battery bank doing? Is it shutting down everything or just this one battery bank? I want to know, I want to find out. Let's do it together. As always, thank you so much for watching. Thanks for all your amazing support here on the channel. It is all very much appreciated. Thank you so much. We are very close to 40,000 subscribers now. I am speechless. I'm far beyond grateful. If I could, I would hug you all. There's no kissing. Just a friendship hug, you know? And until the next video, you stay charged, exactly, stay charged. Don't go that high. This is only for testing purposes. 55.2 is enough. Stay safe, and thanks again for watching. See you then. Bye-bye. So, there you go. And here it tells us warning. Yes, we are in warn level.